Hi, and welcome back. In the previous video, we looked at Python's built-in data structures. In this video, we're going to take a look at a feature of Python that is significantly different from C, C++, or Java. In Python, functions and classes are first-class objects. The phrase first-class object is a fancy way of saying something is a data value that can be accessed, modified, stored, and otherwise manipulated by the program it's a part of. In Python, a function is just as much a data value as a text string is. The same goes for classes. When a function definition statement gets run, it stores the resulting function in a variable with the name that was specified in the def statement. That variable isn't special. It's just like any other variable holding a value. That means we can use it in expressions, assign the value to other values, or even store a different value in place of the original function. The function value itself contains quite a few attribute variables which we can access. More usefully, most of the time, we can add attributes to a function object, allowing us to store custom information about a function as part of the function and access that information later. One common task that first-class functions make easy is assigning handlers to events. To bind a handler function to an event in Python, we just pass the function object as a parameter when we call the binding function. That's a significant improvement over the hoops that C++ or Java imposes on us to do something similar. Like function definition statements, class definition statements create a class object and store it in a variable. That can be confusing at first. Classes describe a type of object. How can they be objects themselves? Think of it this way. A blueprint for a house describes a type of building, but the blueprint is still a thing in its own right. It's the same with class objects. This means that like function objects, class objects can be stored in variables and otherwise treated as data values. Most interestingly, they can be used as parameters to function calls. As an example of why that's interesting, consider this. Python's standard library contains a data structure class called defaultDict, which is like a dictionary, except that when we try to look up a key that isn't already in the dictionary, it creates a new value and adds it to the dictionary before returning it to the code that tried the lookup. How does a defaultDict know how to create the default value? It knows because we gave it a class as a parameter when we created the defaultDict. Thus, if we want a dictionary of lists, we could give the defaultDict the list class as its how to make a default parameter. As an aside, defaultDict can also work with a function as its how to make a default parameter. The defaultDict actually doesn't care what that parameter is, as long as the object we passed can create a new object whenever the defaultDict needs a new default. That's an example of the duck typing we mentioned in the previous video. It doesn't matter whether the parameter is a function, a class, or anything else, so long as it behaves properly. If it doesn't behave properly, we'll be told what went wrong and where. We saw a little while ago that we could add attributes to function objects, which is often handy. We could do something similar with classes with one big difference. Attributes we add to functions are only visible to code that has access to that function object, which usually doesn't actually include the code of the function itself. Attributes we add to class objects are visible to any code that has access to the class object or to an object of the type described by the class. That means that if we add an attribute to a class, the functions defined in that class will be able to access that attribute. Through the self parameter, we need to be careful when adding attributes to classes. because if we accidentally overwrite one of the class's attributes, we could break the class. We have a greater ability to manipulate classes than functions. So, we need to use that ability more thoughtfully. Also, notice that in this example, one of the attributes we added to the class is a function, which then proceeds to work exactly as if it had been defined as part of the class from the beginning. In this video, we have looked briefly at what it means for Python to have first-class functions and classes and how that can affect the possibilities open to us as programmers. In the next video, we'll take a short tour of some of the highlights of Python's standard library.